Okay, can you view already the screen that I'm sharing?
Oh, yes, sir.
All right, so couldn't find the make the maple work things out. I'll do that tomorrow. We need some more time to reach out on maple. All right, so let's just make comparison again. Here, if you use a left Riemann method or right Riemann method, you need 100,000 point. Okay, 100,000 point. If you use midpoint, you only need 160 points for the same precisions, 10 to the negative 5. Okay, so that means you get 4-digit correct. Okay, the difference is only on the let's see, that's the first digit 5. Yes, you get 4-digit correct behind the separators. Okay, so that's already a big improvement from 100,000 down to 160. Okay, well, let's do uh, the parabolic method, because that's so far what we have as the most sophisticated tools we have so far. So use this the parabolic method. Sorry, it's a method. Some says that this is Simpson's rule, Simpson's method. I'm sure this is not the same as Simpsons and Bart Simpson's. Same thing, same name, but a really different history. All right, so let's get the formula for the derivative. Sorry, formula for the error. Right, so this is the error formula. Let's get this. Oh, sorry. I don't need this one. Here, just need this one. Okay, and it. Okay. All right. The thing with the parabolic method, we need forced derivative. Okay. We need the fourth derivative. So we need the compute the fourth derivative. All right. Okay, let's see here. This is second derivative. Just need to compute derivative quite a lot actually. Okay, so all right, uh, second derivative, and then that's the word. Okay, let's move this up with so. Okay, so that's first derivative, second derivative, third derivative. The derivative is just okay, 2 cosine x squared. This is easy. Cosine become negative sign. 2 to x, therefore x. There's it. And then next is 8x. Okay. Oh, sorry. 8x. 8x times sine. Okay. Tan sine become cosine, so another 2x. So you have okay. So what we have here is that here we have that's negative. The sign is let's see 8x plus 4x squared x squared. And then you also have that cosine is okay. And the fourth derivative, right? Take derivative again. Derivative of this one. Here we have actually we don't need this one later on. It's computed. Okay, derivative of this becomes 8 negative. Okay, sine x squared. And then derivative of sine and cosine 2x. So minus 8x squared cosine x squared. Okay, and then we have derivative of this 8 sine x squared. Sine become cosine. So it's x squared sine x squared. Now this one 16x, yeah, sine x squared. And last is cosine, negative cosine become plus then. X cubed. Now, sine x squared. All right, so let's simplify this one because this is the thing that we what we need. Okay, so this sine x squared, many you have is 8x 8 plus 16x cubed. How many cosine? Minus 8x squared. Let's see. Minus 16 minus 16x there. Okay. All right, so let's estimate this one. Oh, we need to an upper bound for f fourth derivative. There. Okay, where c is between 0 and 1. Okay, so let's see here. So f why I didn't write using that. Just put this there. C is less than, say, sine square is less than 1. This was less than 1. Okay, this is less than you add the positive part all together. So 8, 8, 16. So this 8, 8, 16, 32. This is just an easy upper bound. You don't need to find an optimum upper bound. That's going to be difficult. Here we have 16, 16, 32, 40. Okay, so this is a precise thing. So you just need to do something easy to find an upper bound. Okay, so let's see. Our EN is E minus 8 is 1. So 1 over 180 n to the fourth. Four times the upper bound for derivative, fourth derivative. Okay, so this is less than 100. This is less than 72. Okay, so 72 over 180. This is less than 1/2. I just use make easy computations. Okay. It should be less than 10 to the, sorry, 1 to the. Okay, so we should have 2 to the x to the fourth is bigger than, okay, that means n to the fourth bigger than, divide by 2. This is 5. Right? Now power 4. This is just 10. Okay, so this is, let's see, what is this? A fourth root of 5. Compute using a calculator if you can. 2 less than 2. 1 something. Just choose because 2 to the fourth is 8 already. Right? 1, if 1, 1, then yeah, that's easy. 2, right? So in the end, conclusions now. To get an approximations of this. With EN less than. All right, so we can make comparison now with the right 3-month. And it holds for left also, because left also has the same formula, except it has negative, but we take absolute value, then the negative won't make any difference. Midpoint. E, this is parabolic. Here, as we want sum, you need 100,000. Here you need only 160. Here you need only 20. Okay, so you see how the improvement goes from right or left Riemann sum to the parabolic method. Okay, and the bulk of the work is that computing derivative and find the upper bound. Okay, questions? Okay, so far? Let me find some example. Other. Okay, these basically same examples. This is an example. Let's see. Change the problem. Okay. Estimate this integral of 1 over 1 plus x. Okay. So 1 to 4. First use wide Riemann sum. And you see that what we need is about, say, 113. Okay. Oh, sorry. This is 1,000. So 112,005. Okay. When you use trapezoidal rule, we have this formula. So solve this. You need 100, say 230, say 238. Okay. So from 100,000, so this is of order 10 to the fifth. This is 10 to the, yeah, this is 100,000. This is 100. And if you use parabolic rule, you only need 18. All right, so you see that's really makes a difference. All right, I'll give you, let's see, where is. Okay, so let's see here. Number 27. Okay. Okay. Let's use the trapezoidal rule to approximate the area of, say, a lakeside. So you have say this is a lake, you have a park, or your property has the shape by the lake, right? Okay, and you need to find out, at least estimate, what's the area of your estate. Okay, and so you make measurement. Okay, so you walk in, two of you probably, one here, standing here, one standing here. Okay, make a measurement here. Here you measure, this is 75, I don't know in which, say, meters. Okay, 75 meters. And then you step by the same time, you step 10 meters away here. and then remeasure, make measurement. Say 71. Step again 10 meters, you get 60. So that's how you get these numbers. The thing here is, well, what can we, how we find the functions? So we remember that we have so far is that, okay, so we see that this is the delta is, let's see, here's 10, okay, n is, let's see, n is 1, 2, 3, 4, 5, 6, 7, 8. So that's even. So we can use trapezoidal rule. Okay. So why we need even? We'll see. Okay. So the approximate is area. Here is that. Oh, trapezoidal rule, right? No, no. So this parabolic. We'll make comparison. Okay. So we see that so the area here is delta times. And then here you have that I just mentioned uh, the rule for the coefficients 1, 2, 2, 2, 2, 2, and then the last one is 1 again. Okay, this is the first one is 75. 2 times. Okay, so just write that down like this. 51, 60, 45, 45, 52, 57, 60, right? And the last one is 59. Okay, so that's give you the approximate area, the estimate for the area. Okay, you need to pick up your calculator. Okay, but if you this is trapezoid method. If you use Simpson, sorry, parabolic, this your area should be approximately. Well, we'll see. What's the formula for this? So we have to go up. Did do that? No, sorry. No. So let's go to the textbook. Now 8 is even, so we can use parabolic because parabolic requires an even number of subdivisions. Where is that thing? All right, yeah. So b minus v over n is the divisions. So it's over 3. Okay. So just delta over 3. So 1 over 3n. Okay. So 1 over 9 is 8, so 1 over 24. Okay, and here the coefficient must be 1, 4, 2, 4, 2, 4, 2, and then the last one is almost last is 4 and then 1. Okay, so let's see. So it's 1/3. Oh, sorry, this delta. Okay, so I should. Here we have delta is 10, 3 over n, so 24. Okay. Times. All right, so let's see. The first one is 75. 4 times 71. 2 times 60. 4 times 45. Now the 45. 2 times 45. 4 times 52. 2 times 57. 4 times 60. And then the last one is 1. Okay, so the 1, 4, 2, 4, 2, 4, 2. That's even the number of the partitions. Okay, because we need to almost end with 4 and then 1. Okay. So that's how you get this number. Okay, questions?
Sir, where did you get the 424?
This?
Can you repeat that, sir? Yeah.
All right, so let's go back to this. All right, I'll tell you about the how you get these things. I won't derive the equations, but just give you an idea. This is 1, 4, 2, 4, 2, 4, 2, 4, 1. Okay, so that's the pattern of the coefficients. That's how it
Okay,
is.
sir. So
Okay.
it's basically from the formula, yeah.
From the formula.
Okay,
Okay.
thank you, sir.
Right. So the reason for that is why parabolic works is that yes. This is the last one for today. Parabolic methods. Method works better than trapezoid. Okay. Just by picture. What's this one? All right, so let's just do all place. Okay. For example, if you have something that looks like this one. Okay. A, say this is B. All right, when you do a trapezoid, say this is this is sample. The shape looks like Example. The shapes look like this one. Say, okay, all right. For example, okay. So if we use a trapezoid, uh, the area should be delta x over 2, y over 2, half of the base times the sum of the length. And the approximation is this one. Okay. So where's the error? This is the error. Why the error occurs? Well, because you have a curve, then you try to approximate the curve using straight line, a segment. Okay, so that's why. All right, so comes the idea. The thing is, what if we estimate the curve by another curve? So the error due to curve by segment, line segment. Right, so all right, so the idea here is estimate the curve by a simple curve. Well, what do you mean by simple curve? Well, the simplest one is quadratic curve. Okay. So quadratic curve is, let's see, now we have something that looks like this. We need to find a quadratic equation, say I. The original is this. Sorry. This is the original. And we need 3 points. Determine a quadratic curve. Okay. Which one? Well, this is one. The midpoint. Go. So from this curve, then you find the area is here is this with this quadratic curve. You can compute this directly. Usually, use integral. So this is, you assume this is ax squared plus bx plus c. Okay. Find a, b, c. Okay. So the area, if we compute this is a, the length of a, the length of this is b, length of this is c. The area would be expressible in A, B, and C, and the formula is, let's see, I think that's the one in the problem. Sorry. Okay. See, where is that thing? All right. Okay. The formula is this A plus 4B plus C. Okay. Divides by delta over, let's see, what is that thing? Over 6, I think. I forget the formula for this. Need to find this. Yeah, that's it. All right. So if you have to, you have two things. Then you have this. Okay, so x1, x2, x3, x4, for example. So this is, we will need one of this, four of this. If we need for this one, okay, so this is plus 2, oh sorry, 4 fx1 plus fx2, right? And then the second one, you get, so think about 2, fx of 2, and therefore fx of 3, and fx, f of x 4. 1 for 1, 1 for 1. See here? 2 of them. There, this will have, so this is 1. If you have that, okay. So you end up with 1, 4, 2, or here in this case would be 4, and then 1. Okay? So that's how you get this pattern. 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, 1. So that's the, we just need that pattern. Okay?
Okay, sir.
All right, so don't worry, because in the exam, you see the formula is given. But the thing here is that you don't need to memorize. What you need is how to use it. You need to know how to use the formula. Okay. All right, so I'll end this session here, and then we'll see you again tomorrow. All right, thank you, and take care. See you tomorrow. I'll stop the record.